Alright, today we're going to continue with our quadratic equations and graphs, but what we're going to do today, instead of getting the equation, figure out the graph features, we're going to work backwards. We're going to have the graph or coordinates of the graph, and we're going to try to figure out what the equation is. So in this case, if we look at this title page, we know our vertex from the graph is at the coordinate 1, 2, and we can see we have like a couple x-intercepts and y-intercepts, things like that, so we could also use, for example, this coordinate 3, 0. So what we're going to see today is if we just have those 2 points, we could work backwards to figure out what that equation of the quadratic is. So in order to figure out the equation, generally what we need to know the vertex and at least one other coordinate. You won't always get these, but generally that's our goal, is to get the vertex and one other coordinate. So we know our formula in vertex form is a times x minus p squared plus q. So what we want to do is, if we know the vertex, we're going to put that as our p and q, because that's what it is in the formula. And then whatever other coordinate we're going to put that in as x or y. So let's go back to that last example. We knew our vertex was at 1, 2, so let's use that for an example. So we have vertex at 1, 2, and we knew our one other coordinate was 3, 0. Okay, so what we're going to do is we're going to actually substitute those things into our y equals equation. So what we want to do is be really careful you get the numbers in the right spot. So for our vertex, the 1 will be the p, 2 will be the q, 3 is going to be 0, x, and y will be 0. So when we plug that in, we'd have 0 for the y equals a, which we don't know, times x, which was 3, minus p, so it's minus 1 squared, and plus q, which was 2. So you can see we have everything in the equation except for a. So that's basically our last step, is to figure out what a is. So we'd have a times 3 minus 1 is 2, and 2 squared is 4, so let's write it as 4a plus 2, and then we just solve that equation. Let's bring the 2 to the other side. So we'd have negative 2 equals 4a, divide by 4. We get a equals negative 2 quarters, or we could reduce that to a half. So once we know the a value, we actually have the equation figured out. We know that we have negative a half for our a. We have x minus p, but we already know that p is 1. And plus q, which was 2. And there's our equation. So if we go back to the first page, we can actually see that is the equation. Minus 1 half times x minus 1 squared plus 2. So it works for any equation as long as we have the vertex and one other coordinate to help us figure out the a. And usually the a is the challenge to the question. So let's do another one. So here you can see, if we look at our graph, our vertex is at 5, negative 4. And let's pick one other coordinate. And if you get the graph, what you want to do is pick a coordinate that is easy to read. So if we look around, here's one here. We got it 4, or 5, 6, 7, 8. That's 8, negative 1. Or we could use, up here is a good one. We have 11 and 8. And there's a couple more. Usually the matching ones will also be pretty good. So any of those points we could use. We need the vertex for sure, and one other one. So let's use the 11, 8. It doesn't really matter which one we pick. So we're going to plug that into our formula. Okay, so we'll use, for 8, we're going to use, or for y, we're going to use 8. A we don't know. X is 11. And our vertex, our p is 5. And our q is negative 4. So let's simplify that. So we get 8, 11 minus 5 is 6. So we have 6 squared, which is 36. Let's bring the 4 to the other side. So 8 plus 4 is 12. 12 divided by 36 will equal 1/3. So from that, we know our equation then is going to be 1/3 a. So that's our x minus p, which is 5, and minus 4 for our q. And that's it. So it's not too tough. You just have to basically make sure you get your coordinates in the right location. So here's another one. So I give you the graph, and I even give you the coordinates, so we don't need to do anything other than just plug it in. So our y is negative 0.5. Our a is what we're looking for. X is 0. P is negative 3, so minus negative 3 would be plus 3. And our q is minus 5, so we solve this one. 3 squared is 9, so we get 9a minus 5. Add 5 to both sides. Divide by 9, we get 1/2. So 4.5 divided by 9 equals 1/2. So our equation for this one should be 1/2 x plus 3 squared minus 5. Okay, so it's pretty straightforward once you get the hang of it. So it doesn't have to be given to you as a graph. They can give you the coordinates. So this is pretty much the same thing. We got our vertex, so there's our P and Q. We got another coordinate, so that'd be our x and y. So we can just plug those in again. So y equals a times x minus p squared plus q. And then simplify that, so we get 4 equals 4 squared is 16. Subtract the 5. Divide by 16, we get negative 1/16 for a. So it doesn't matter whether you do decimals, fractions. Usually we just leave them as fractions, but it will work either way. So we'd have x plus 2 squared plus 5 would be our final equation. One more, and this one's worded a little bit different. You can see we've got a vertex, we have our P and Q, but they're saying it's congruent to y equals negative 2x. The word congruent in English means equal in shape and size, but in a different location is kind of how you want to interpret that. So that means if we had a graph y equals negative 2x squared, it's going to be a graph something like that. So that means our new one is going to be basically the same graph, but we've moved the vertex over to 3 minus 2. So it's just going to basically be the same graph shifted over. So that means if we don't change the shape of the graph, that means our a value still has to be the same. And if it's not reflected upwards or anything like that, we definitely keep it exactly the same. We use negative 2. If I said it was congruent to y equals negative 2x squared but opens up, then all we'd have to do is change it to plus 2, but it would be the exact same number. So this one's actually pretty easy because we know our a value is negative 2. So we can just plug that in. We know our p and q. And we're done. So we don't even have to do any other simplifying. And that's it for today.